Okay, we're live. Today we're doing volume. Volume being the three-dimensional space occupied by an object. And all the objects we're going to do in this course are, of course, regular solids that we can calculate. Volume is always measured in units cubed. What do we mean by cubed? Well, in other words, like centimeters cubed, meters cubed, and of course you could have non-metric ones like feet cubed or cubic inches, which is the way they still sell freezers and they still talk about how big an engine in a car is, how many cubic inches it is. Having said that, and etc., you can have any kind of unit you want and you just cube it. Having said that, I did want to make the point that we've talked a lot this unit about the difference between the imperial system and the metric system. The imperial system. And there are some exceptions to that. The medical industry is mostly metric. Think about it. Have you ever watched a hospital drama that you know was made by American television? They'll say, give me so many, give me 100 cc's of something. You know what they're saying, right? Cubic centimeters. When how much of a drug you give could affect somebody's live or die situation, they don't mess around with ounces because they're quite imprecise, whereas the metric system is much easier to work with and more precise. So the Americans do use metric when it matters. So just thought that was kind of interesting. Moving along, let's start with prisms. The volume of a prism. Okay, most people learn this formula way back in elementary, but they learned it actually in a specific way. You might have learned that the volume of this thing is length times width times height, and you're not wrong. But that's specific to a rectangular prism. What if it has a square base? What if it has don't have to draw this, a triangular base? Now you're probably going to go, wait a minute, it's sitting on a rectangle. Isn't the rectangle its base? No. I call this a triangular prism. So even though it's not sitting on it right now, that's the base. The triangle is the base, or the other triangle. I could make you a pentagonal prism, if I could draw. That's not too bad. And there we go. And connect the dots. There we go. I could have a pentagonal prism, right? The base is the pentagon. So actually, the formula for any prism, volume equals, and I'm just going to write it as capital B times H. Capital B is not a line. What this is saying is area of the base. The base is one of the faces, and in fact it's the face that the object's named after. This is a rectangular prism, so you can call any one of these the base. Any one of these rectangles is the base, and length times width times height will give you the formula. But if it was a triangular prism, this B stands for the area of the triangle. If it was a pentagonal prism, this B stands for the area of that pentagon. Height here stands for the, again, height of the prism. So again, you can put this in words if you like. Volume is area of base times height. And we don't give you that formula. We expect that you kind of understand it logically. So let's do a couple. Let's start with a rectangular prism. So a rectangular prism, it doesn't matter which way it's facing. I could call this part the base. I could call the part it's sitting on the base. It doesn't matter. Everything it sits on is a rectangle. So the volume is the area of the base. I'll take the 5 by 9 and call that the base. So area of the base times how tall it would be if it was sitting on the base, which is 5 times 9 times 13. I won't bother showing you the button punch on that. 585 cubic inches. Okay, look at the next one. It doesn't matter if it was sitting on this rectangle. The base is the triangle. It's sitting on the base right now, at least it looks like in this picture. It looks like it's sitting on that triangle. So the triangle is the base. So the volume here is, again, the area of the base times height, but this area is base times height divided by 2. And okay, now notice, this is a little confusing. This B and this B don't mean the same thing. This B meant an area of a face, and this little b meant how long this line is. Notice the two h's don't mean the same thing either. This height means height of the prism, which is actually this line right here. What does this height mean? It means the height of the triangle, which I'll just draw an arrow to it, is that, right? So the area of my base is 14 times 15 divided by 2. And when it's sitting on the base, how tall is the prism? 18. And again, that's a pretty easy calculation, so I'll just show you the answer. When I punch buttons, it's 1,890, and now I'm in cubic yards. So there's prisms. Now, the next object isn't technically a prism, but it behaves like a prism. Cylinders. Cylinders are kind of prisms, right? The definition of a prism is it sits on the base, whatever it is, triangle, rectangle, pentagon, whatever, and then all of the faces that go up laterally, are rectangles. Well, if it's sitting on a circle, remember we looked at this the other day, if I unravel that, it is a rectangle. So it behaves like a prism. That, by definition, though, prisms don't have curves on them. But there we go. It behaves like a prism, and that means I have the same formula. Formula is area of the base times how tall it is. But now we're going to have a specific formula, because the area of the base here, well, the base it's sitting on is a circle. So it's pi r squared h. Or again, I can think of that as the area of a circle and how tall the cylinder is. I could say when it's sitting on the circle, but that's pretty obvious, I hope. So that's the formula, pi r squared h. Notice it's actually less work than the surface area formula, which had 2 parts. Right? So let's do a couple. Let's do the volume of this first cylinder. Volume equals pi r squared h, which is pi times 15 squared times 12. Okay? All right, I'm going to use a different calculator than I used in my video the other day, because I have a couple people in my classes that have one of these calculators, and it's freaking them out because it's not doing what they want it to do. So if you have one of these kind of fancy Casios, or actually there's some fancier Sharps that work this way too. Okay, first of all, never punch in 3.14. You have a pi button. It's right there. It's the shift on the exponent button. So I go shift pi. Notice it says pi times 15 squared. I mean, I knew that was 225, but let's just punch it anyway. Times 12. And this is what's messing with them. They're going, hey, wait a minute. I wanted the answer to 2 decimal places. It's not giving me a decimal. Yeah, this is giving me an exact answer in terms of how many pi's it is. But if you have this type of calculator, every one of these calculators has a little button like this. Look for it. S arrow D. And that toggles you back and forth between exact answer and decimal. Right? So look for that. So that this case, I want 2 decimal places, so I round it to 30. So it is 8,482.30, and we're in centimeters cubed. Okay? So guys who are asking me about these calculators, hopefully that helps you out a little bit. All right, let's do the next one. Determine the volume of the following cylinder. This one throws a very minor complication. Do you see it? They're trying to mess with you. What's the trick here? Yeah, they don't give me a radius, they give me a diameter. So my only thing I have to do before I hit my formula is change that to 9 millimeters. Get it? Half the diameter is radius. So I'll just go to the formula this time. Pi times 9 squared times 21. Somebody this morning asked me why I bother putting this 9 and this 15 in a bracket. You're right, I don't need them. But I kind of trained myself from a very young age to always replace a variable with a number and put it in a bracket so I don't mess up bedmass. So that's kind of just a habit I've had. It's not really necessary. You don't have to do it that way. And I punched buttons on this morning, and I got 5,343.85. And this time it'd be cubic millimeters. Let's just stop to think about this. Sometimes students find these answers really, it's like, oh, I must be doing it wrong. Look at how huge these are. But that kind of makes sense. Like, think about it. A cylinder that's 15 by 12, well, you know, 15 centimeters is probably about the width of my hand, and 12 centimeters is about that. And if I had a cylinder that big, that's like a larger Tupperware container, it's going to hold a lot of cubic centimeters. Think about a ruler that's in centimeters. I don't seem to have one handy. I had one a minute ago. Oh, here, that's close enough. Right? Think about how small a centimeter is. Now imagine a cube where that's an edge. It makes sense that a lot of them would fit into a fairly big Tupperware container. I was pointing out this morning that this box here, let me back up a little. This cube here that I've been using as a pen holder on my desk for the last, don't want to say 25 years probably, that's 1,000 cubic centimeters. Because it's, here, I'll show you. It's 10 centimeters this way, right, 10. It's 10 centimeters this way, and if I go that, it's 10 centimeters across that way. So 10 times 10 times 10, that's 1,000 cubic centimeters. Anybody else know what you call 1,000 cubic centimeters? That's a liter. That is a 1 liter container. A liter, by definition, is 1,000 cubic centimeters. A cubic centimeter and a milliliter are the same thing. Okay, so keep that in mind. It is normal for your volume numbers and answers to look bigger on the same object than the surface area number does. So don't let that mess with you. Okay? All right, let's get back to, let's go to pyramids. Okay, we did a little activity before we started the video where I showed by pouring some water that there's an interesting relationship between a pyramid and if this pyramid exactly fit into a prism, like, well, I guess I drew that badly. I should have cut it off there. Oh, there. Well, this is all messed up now. There. There. If this thing exactly fit in to a prism, where that was right in the middle of the roof, it's hard to believe looking at it, but the relationship between how much volume the prism has and how much volume the pyramid has, the pyramid's a third. I know it looks like it's maybe half. It isn't half. It's actually a third. We kind of have to go kind of fast in this course. I'll put some links to some videos. There's some great videos online with animations and stuff that show you that you can actually prove that relationship with just a little bit of math beyond high school. This is one of the first things you'll talk about in calculus, is if you take calculus of shapes, is how do you prove that this thing's 1/3 of that thing. It's very fun. So we're just going to use it as a rule. I've kind of shown you by demonstration just with water that it's true. But the volume is 1/3 of the area of the base times how tall it is. Okay? Now again, careful, careful, careful. I'm actually going to write it in words this time. Careful. Is there 2 L's in careful? No. I don't think so. Careful. Careful. This height is the height of the pyramid. And what do I mean by the height of the pyramid? From center point of base directly to apex. Am I still on the screen? No. Okay. It is not slant height. Exclamation mark, exclamation mark. That's the most common mistake I watch students make when they're doing these calculations. They mix up which height is which. Do you get what I mean by that? Remember when we were doing surface area? When we were doing surface area, we cared very deeply about this height here because I have to find out how much area this triangle has, and that's the height of that triangle. I don't care about the height of this triangle. When I'm doing volume, I care about the height of the pyramid, that one. So make sure that makes sense to you, that they're 2 different heights, and in this formula, the one I want is the height of the pyramid, not the height of the triangle that makes the pyramid. Clear as mud? Awesome. Let's try an example. Maybe that'll make it easier to understand. Okay, so determine the volume of a right rectangular pyramid. And again, I have to say right rectangular so you know that this apex is directly above the center of the base. So the volume is 1/3 of the area of the base times how tall it is. So the volume is 1/3. The area of the base here is, it's a rectangle, so that's 4.7 times 3.6. And the height is that it's 6.9 meters tall. Okay. Now, again, I wouldn't mind showing you on the calculator how to punch that, because I get some students who have a tough time figuring out their fractions. I actually would like you to use your fraction button. I want the most accurate answer I can get before I round. Don't just go, I know a third's 0.3, so I'll just hit decimal and mash some 3's. That's a bad habit. You have a calculator capable of fractions. Why don't you actually use it? So I'm going to go on this calculator. Again, this is the fancy kind. That's my fraction button, and I have to hit it first. And I go 1 over 3. And then what was the rest of the calculation again? Times 4.7. Oops, back up. That's wrong. Hang on. Delete, delete, delete. I forgot. I got to move the cursor over there. Times 4.7. That's better. Times 3.6. Times 6.9 equals. Oh, look at that. There it is again. This stupid calculator doesn't want to give me a decimal. Yes, it does. You just have to ask it nicely. Please give me a decimal. There you go. Okay, so 38 point, I'd say 92. I have some people looking at me with confused faces. They don't have the same kind of fraction button. Do you have a kind of a fraction button like this guy? There are some calculators that don't have it at all. You're going to have to, I'm sorry, just go 1 divided by 3. That's the best you're going to do. This calculator here, or I guess you could go decimal and then just keep mashing 3's till you run out of screen room. This calculator here, though, before you say you don't have a fraction button, check for, can you see above my finger? Check for that. That's your fraction button. So here, on this calculator, the calculation would look like this. It would be 1 over 3. Notice I hit the button as the over when I say it. Times, and what was the rest of it again? 4.7 times 3.6 times 6.9 equals, there it is, same number. Okay? So if you haven't been using your fraction button up till now, get into the habit of using it. It makes calculation much easier. Okay. All right. What is the trick in this one? Again, they're messing with it. They're throwing something at you hoping you make a mistake. See that 7 foot? What line is it pointing to? It's pointing to the slant height. I don't want that number. I want the number that goes from here straight up to the apex. So that's this line. I just made it. And I don't know what it is. I'll call it my height. They gave me a slant height of 7. And we had this yesterday. Obviously, if that's a slant height, then that's a right angle. How do I figure out that number again? Oh yeah, it's a square base, so it must be half of an edge. Ta-da! So I got to do a Pythagoras on this. So h squared plus 1 squared equals 7 squared. Don't forget, the hypotenuse always goes on this side, right? So h squared is equal to 7 squared minus 1 squared. H squared is equal to 49 minus 1, which is 48. And we did this yesterday. I don't want the decimal here. That's not my final answer. I don't want to round things already. My calculator can handle root 48, no problem. So I'm going to just work with root 48. And I'm ready for my next formula. So now that I know that height, volume equals area of the base times height, which is, well, the area of the base is a square. So 2 squared times root 48. Oh, sorry, I forgot. A third. This isn't a prism, it's a pyramid. Thank you. 1/3 base times height, which is 1/3 times 2 squared times the root of 48. And again, fancy calculator would do it like this. Open a fraction. 1 over 3. Move the cursor over times. And then what did I have? 4 times root 48. Boom. Oh, and it keeps wanting to give me a simplified radical. I don't want that. I want a decimal. There we go. 9.2, I got to round it to 4. And what are we in? Cubic feet. Okay. So there's pyramids. One more for today. Oh, wait. Sorry. Am I going too fast? Sorry.
Can you just go up with it?
I could. There. Is that better? Okay. So we got one more shape, and again, kind of like the cylinder was really just the same formula as the prism. Well, guess what's the same formula as the pyramid? Cones. You could just come and get this from me if you follow behind me. Cones are next. Volume of a cone is the same formula exactly. It's still 1/3 of the area of the base times the height, but in this case, the area of the base is a circle. So it's 1/3 pi is r squared height, and again, this part is the area of the circle, and this part is how tall. And I'll say how tall, not slant height. It is not how long this line is, it's how far it is from the center of the circle to the apex. Okay, let's do a couple of these examples here. Use our fancy new formula. So volume is 1/3 pi r squared h. All right, they've already, on the very first one, they've thrown that little complication at us. Is 8 my radius? No, 4 is my radius, so don't fall for that. So that's 1/3 times pi times 4 squared times 13. Okay, if you want practice punching buttons to make sure you're doing it right, you could pause the video at this point and then start it up again once you're done punching buttons. But I got 217.82 millimeters cubed, cubic millimeters. If you think centimeters cubed are small, think about how small cubic millimeters are. So it makes sense that in this little cone there's a lot of them. All right. Example 8, yet another trick they're throwing at us to try to mess with us. What is the trick in number 8 here? They didn't give us a height, they gave us a slant height. So back to Pythagoras. I need that height. That's 17. The radius is 7. Somebody asked me this morning, how do you know that it's always 7 to every edge? Well, because that's the definition of a circle. A circle has to have the same radius to everywhere from the center to the edge. Okay, so there we go. H squared plus 7 squared is equal to 17 squared. H squared is equal to 17 squared minus 7 squared. H would then be the square root. 289 minus 49 is 240. And again, I don't care what that decimal is. It's just a stepping stone to my answer. It's just a pawn in my little game. 1/3 pi r squared h. So I have 1/3 times pi times r, which is 7 squared, times the square root of 240. There we go. Punching buttons on my calculator. I'm going to run through this one again. I'll use the other calculator this time. I'll keep it. I'll mix it up. Okay, so this one is 1/3 times, where's pi on this one? I've already forgotten. Pi, where are you? There you are. Pi times, I don't need to know what 7 squared is, 49, times the square root of 240. And there it is. 794 points. I want 2 decimal places, so 93. So 794.93 cubic inches. There we go. All right. This is another good place to maybe pause the video and try example 8 for yourself and see if you could get it. But I actually don't have a pause button on this particular recorder, so we just have to keep going. So here it is. I got a cone. I'm going to draw it. Cone. I know its height, so from center to here is 8. I know its volume is 300 cubic meters. I don't know what its radius is, and I'd like to figure that out. Okay, well the formula is, volume is, oops, I keep forgetting the 1/3. 1/3 pi r squared h. I know the volume's 300. I know what 1/3 is, I know what pi is. I don't know r, and I know h is 8. How am I going to solve that? Well, I'm going to use algebra. Okay, I need to isolate r. What are all these numbers doing to r? They're multiplying. What will they do on the other side of the equation? They'll divide. So r squared, just flipping the equation over, is 300 divided by 1/3 times pi times 8. That's even not my answer yet, because I don't want to know what r squared is. I want to know what r is. Oops, I don't know why I put 3 lines there. R is equal to the square root of 300 over 1/3 pi times 8. And the challenge I was asking the kids this morning is to, again, well, we could artificially pause the video here. Can you punch that in one calculation in your calculator and only hit the equals button once? It involves multiple brackets, at least on most calculators. Here, I'll use the fancy one again. So, I need a big square root, and then I need 300 divide by, and then I need to open a bracket, for the denominator. If you don't open a bracket for the denominator, it won't work. And then I need a fraction, 1/3 times, and where's pi again? Pi times 8, close my brackets, it equals, and I get 5.98. Is that what you got?
Yeah.
Okay, good work. That means you're using your calculator very, very well. If you take applied math, your applied math teacher will be very happy with that. So 5.98, and this is meters, right? Because this is a radius, it's not an area, it's not a volume, it's not cubed or squared. And there we go. That is prisms, pyramids, and cones. Oh, and cylinders.